Have you ever gazed up at the night sky and felt a sense of wonder? The cosmos is vast, filled with more stars than there are grains of sand on all the beaches of Earth. Each star could be a sun to its own family of planets. But what if we could shrink that vastness? What if we could take the fundamental ingredients of the universe and create a new, tiny reality right here in a laboratory? Imagine a special container, a vessel not much bigger than your hand. Inside, we place simple things, the oxygen we breathe and tiny shimmering particles of gold. Could this humble box, with a little help from light and pressure, become the seed of a new universe? It sounds like something straight out of a science fiction masterpiece, a tale told on a flickering screen, yet the questions it raises are rooted in our deepest curiosities about the nature of existence itself. The universe we know began with a Big Bang, an event of unimaginable energy and density. From that singular point, everything we see today expanded outward. Space, time, and all the matter and energy within it came into being. So when we talk about creating a pocket universe, we are asking a profound question. Can we replicate the conditions of creation on a miniature scale? Can human ingenuity spark a new fabric of space-time? The idea is both thrilling and humbling. It forces us to confront the limits of our knowledge and the boundless potential of what we have yet to learn. The journey to answer this question isn't just about building a new world, it's about understanding our own with a clarity we've never had before. This quest begins with the most basic elements. We choose oxygen because it is vital for life as we know it, a reactive element that drives countless chemical processes. We choose gold, not for its monetary value, but for its unique properties at the nanoscale. When gold is broken down into particles a billionth of a meter in size, it behaves in strange and wonderful ways, interacting with light in a manner that larger pieces simply do not. These aren't just random ingredients, they are carefully selected components in a grand cosmic experiment. We are attempting to assemble a puzzle, hoping that when the final pieces are in place, the image they form is one of a reality entirely separate from our own, a self-contained bubble of space-time. The thought experiment we are about to embark on is a dance between established physics and speculative theory. It's a journey to the very edge of what we consider possible. We will explore how simple actions like shining a light or applying pressure could theoretically warp the very fabric of reality. This is the heart of scientific exploration, asking what if, and then methodically, step by step, seeking the answer. We are not just mixing chemicals in a beaker, we are probing the fundamental laws that govern everything. So let your imagination take flight. Let's walk the line between the known and the unknown, and see if we can find the recipe for a universe in a bottle. Let's begin our cosmic construction project. First, we take our sealed, transparent container. Inside, we introduce pure oxygen gas, its molecules bouncing around freely. Then we add our magic dust gold nanoparticles. These are not shiny nuggets. They are microscopic specks, so small that millions could fit on the head of a pin. We need these particles to stay suspended, floating evenly throughout the oxygen, creating a kind of shimmering golden fog. To achieve this, we might circulate the gas gently, ensuring our ingredients are perfectly mixed. This isn't just a random mixture, it's a carefully prepared medium, a stage set for the main event. Each gold nanoparticle is a tiny antenna, ready to receive a very special signal from the outside world. Now, we introduce the catalyst for our creation light. But this isn't the ordinary light from a lamp. We need an intense, focused beam, like that from a powerful laser. To make it even more special, we shine this light through a precisely cut crystal. A crystal acts like a lens for light, but it does more than just focus it. It can organize the light waves, making them coherent and orderly, like soldiers marching in perfect step. As this organized, intense light enters our container, it strikes the countless gold nanoparticles. The particles absorb this energy, and because they are so tiny, they begin to vibrate, to heat up, and to interact with the surrounding oxygen molecules in extraordinary ways. The container is no longer a quiet box, it's a storm of energy and light. The final ingredient is pressure. As the light energizes the gold nanoparticles and heats the oxygen, the pressure inside the sealed container begins to build dramatically. But we can also apply immense pressure from the outside, squeezing our container with forces that mimic those found deep within a planet's core or at the heart of an exploding star. According to some very speculative ideas in physics, extreme energy density, that is, a huge amount of energy packed into a tiny space, can do strange things to space-time. It could, in theory, cause space-time to curve in on itself so dramatically that it pinches off from our own universe, like a soap bubble detaching from a wand. This combination of factors, the energized nanoparticles, the circulating gas, the focused light, and the immense pressure, creates what physicists call an exotic vacuum state. It's a condition where the normal rules of empty space no longer seem to apply. Is this enough to create a pocket universe? The truth is, we don't know. Our current understanding of physics, including Einstein's theory of general relativity and quantum mechanics, suggests that the energy required would be astronomical, far beyond anything we can currently generate. It remains a concept on the farthest frontier of theoretical physics, a beautiful idea waiting for a breakthrough. But the very act of thinking about it pushes our science forward. Let's shift our focus from the creation of universes to the universe within our own bodies. Everything in the cosmos vibrates, from the gentle hum of the earth to the atoms in your chair. Everything has a natural frequency at which it prefers to oscillate. This is called a resonance frequency. Think of pushing a child on a swing. If you push at just the right moment in each arc, matching the swing's resonance frequency, the child goes higher and higher with very little effort. If you push at the wrong time, you might stop the swing altogether. This principle applies to everything, including the cells that make up our bodies. Every organ, every tissue, and every cell has its own unique vibrational rhythm. This concept leads to a fascinating, though highly controversial idea in alternative medicine. Could we use resonance to heal? The theory suggests that disease cells, like cancer cells, vibrate at a different, less coherent frequency than healthy cells. What if we could broadcast the specific resonance frequency of healthy cells into the body? The thinking is that this could act like our perfectly timed push on the swing. The healthy cells would absorb the energy and grow stronger, while the chaotic, unhealthy cells would be disrupted and destroyed by the same frequency, unable to handle the orderly vibration. This idea of resonant frequency therapy is explored by some as a non-invasive way to target illnesses without harming the surrounding healthy tissue. The idea of resonance doesn't stop with disease. Some proponents believe it could even influence the aging process itself, right down to our DNA. At the very tips of our chromosomes, the tightly coiled threads of DNA in our cells, are protective caps called telomeres. You can think of them like the plastic tips on shoelaces that prevent them from fraying. Every time a cell divides, these telomeres get a little bit shorter. Over a lifetime, they become so short that the cell can no longer divide safely, and it enters a state of old age, or senescence. This shortening of telomeres is one of the key biological clocks that dictates our lifespan. Could resonance frequencies somehow protect these telomeres? The hypothesis is that by bathing our cells in specific life-affirming frequencies, we might be able to slow down or even reverse this fraying process. Perhaps these vibrations could help the enzyme that maintains telomeres, called telomerase, to do its job more effectively, keeping our cellular shoelaces intact for longer. This would, in theory, allow our cells to remain youthful and vibrant, pushing back against the biological tide of aging. It's a captivating thought that we might one day tune our bodies like an instrument, restoring harmony and extending our healthy years through the simple power of vibration. So, where does mainstream science stand on these incredible ideas? Let's start with our pocket universe. While the concept is a staple of theoretical physics, particularly within string theory and cosmic inflation models, the practical creation of one is firmly in the realm of science fiction for now. The energy densities required are simply colossal, far exceeding the power of our largest particle accelerators, like the Large Hadron Collider. Scientists agree that packing energy into a small space can warp spacetime. This is a core prediction of Einstein's general relativity, proven by countless experiments. However, pinching it off into a new universe is a leap that our current science and technology cannot make. It remains a tantalizing what if. Now, what about resonance frequency therapy for cancer and anti-aging? Here, the scientific community is highly skeptical. While it is true that cells and molecules have vibrational frequencies, the idea that we can selectively destroy cancer cells or repair DNA with external frequencies is not supported by robust, repeatable clinical evidence. The human body is an incredibly complex and noisy biological system. Picking out a specific cell type and affecting it with an external vibration, without disrupting the trillions of other cells, is a monumental challenge. Most claims of success come from anecdotal reports or small-scale studies that lack the rigorous, placebo-controlled design required for medical validation. The science of telomeres is real, but slowing their shortening through resonance remains an unproven hypothesis. This is where we must draw a clear line between what is known and what is imagined. Science thrives on imagination. Every great discovery began as a wild idea. The thought of a pocket universe pushes theoretical physicists to refine their models of the cosmos. The idea of vibrational healing, while not currently supported, encourages us to explore the subtle energetic properties of biological systems. But for an idea to move from imagination to reality, it must pass the test of evidence. It must make predictions that can be verified through experiment. It must be repeatable, reliable, and stand up to the scrutiny of experts around the world. And this is the beauty of the scientific process. It invites us to dream, to wonder, to ask the biggest questions we can conceive. Can we create a universe? Can we conquer aging? These are not foolish questions. They are the expressions of our species' innate curiosity. While the specific methods we've discussed today may be more fiction than fact, they inspire us to keep searching. The universe is under no obligation to make sense to us, but our quest to understand it is the most noble adventure there is. So, keep looking up, keep asking questions. The next great discovery might be waiting just beyond the edge of what we think is possible.